welcome back to our channel. My name is Teacher Roger, and today we are going to solve a long calculation problem using grouping. To explain this topic, I have chosen this question. So let us take a look. Alright, so the problem states to calculate 1 plus 2 minus 3 minus 4 and so on all the way until plus 2013. Wow, this looks super long, right? But don't worry, there's a clever way to group these numbers so that the question can become much easier. Let us start with an easier example first. Let's look at this string of numbers. So we have 10 minus 9 plus 8 minus 7 all the way until plus 2 minus 1. So let us try the normal way first, step by step. What is 10 minus 9 equal to? 1. Excellent. Then we move on to take 1 plus 8, which will give us what value? 9. Very fast calculation. Let us continue to subtract 7, which will give us what value again? It will give us 2. And we have to repeat this operation all the way until finally we get 6 minus 1, which will give us a final result of 5. So the final answer is actually 5. Yay! We solved this question. However, there's a lot of steps, right? It feels too long. Now, I will show you an easier way. Let us look for patterns. What is your first observation on the numbers? Exactly, the numbers are getting smaller and smaller. What is the second observation regarding the signs? That is correct. The signs are repeating from minus to plus, and so on. Since the numbers are getting smaller and smaller, and the signs repeat after every two numbers, let us see if the numbers with these signs have a special relationship. Let's look at 10 minus 9. What is their difference? 1. Excellent. How about 8 minus 7? Yes, 1 again. How about 6 minus 5? Also 1. So we can group them into pairs because 1. The signs repeat after every two numbers, and 2. Each pair of numbers have the same difference of 1 each. Now, let us group the numbers based on their repeated signs and their difference in number. So 10 minus 9 is equal to what? Yes, 1. How about 8 minus 7? Also 1. How about 6 minus 5? 1 again. 4 minus 3? Also 1. And finally, 2 minus 1? Also 1. Now, big question. How many 1s do we have? Yes, exactly. We have 5. So the final answer is 5 again. See? So by grouping using the repeated signs and the number pattern, we get the same small result from each group, which makes this long calculation super easy. Now, let's do a summary for grouping numbers. Firstly, is it easy to calculate normally for long calculations? No, it is too long to do so. Next, what do we do to make long calculations easier? Exactly, we can observe repeating signs and their number relationship as a guide to group these numbers together. Finally, what are the results of each number group usually? Very nice, they usually are equal. Now, let us move on and look at example 2, which are the first 13 numbers of our main problem. So we have 1 plus 2 minus 3 minus 4 and so on all the way until minus 12 plus 13. How can we group these numbers so that we can make the long calculation easier? First, let us try to group these numbers into groups of 2. The signs do not repeat and we cannot work out minus 3 and minus 4. So this grouping was not helpful. How about grouping them into groups of 3? Now, again, the signs do not repeat and we cannot work out minus 7 and minus 8. So this grouping was also not solvable. How How about grouping them into groups of 4? Now the signs seem to be repeating with a pattern of plus, minus, minus. However, we still cannot work out as the groups, they sum up to below 0 value. So this grouping was not workable as well. It seems like we cannot group them accordingly based on their number or their sign pattern. What should we do here? Don't worry. Let us use an easier example to understand the grouping techniques better. Imagine we are all playing with building blocks, and each building block has a letter A, B, C, and D. First, we line them in order, and we start with block A. What pattern do you see? Very good observation. It is A, B, C, D, repeating again and again. Now, let us remove the first block, block A. The new starting block is now block B. What pattern do you see now? Excellent observation. It is the pattern B, C, D, A, repeating again and again. So what do we learn from this simple building blocks example? We do not always have to start from the very first block to find a pattern. As long as the letters repeat in the same order, the pattern stays the same no matter where we start the grouping. Now, we have saw the signs keep repeating in a group of 4 with the signs with plus, minus, minus. Now let us recall the building block example. We do not always need to start with block A. Same here. We do not always need to start grouping from the first number. Why? Because look at the first number, like 1. They are too small to be subtracted from. So let's shift the grouping to start from number 2 instead. Let's try. So we have the first group, 2 minus 3 minus 4 plus 5. Let's watch carefully. 2 cannot minus 3. So let's just jump ahead and add 5 first. So what is 2 plus 5 equal to? 7. And 7 minus 3 minus 4 will give us a value of 0. Yay, this works. Let's test another. So we have 6 minus 7 minus 8 plus 9. So what was the trick that we did? Jump over. Very good. So we take 6 plus 9 and we will get a value of 15. And 15 minus 7 minus 8 will give us a value of 0. Let's do one more. So we have 10 minus 11 minus 12 plus 13. So we take 10 plus 13 to give us 23. And 23 minus 11 minus 12 will give us 0 again. Wow! So each group sums up to give us 0. And the final example, the final answer for this whole example is just 1. Amazing, right? So let us summarize from what we have learned for how to group numbers. What do we observe when we want to group the numbers? Yes, we group the numbers by looking at the repeating signs and their number relationships. Next, what is the result from each group usually? Very good. Each group usually gives the same result. For instance, example 1, each group add up to give a value of 1. And for example 2, each group sum up to give us a value of 0. Yes. So finally, do we always have to start grouping from the first number? Not at all. We don't always need to start from the first number. We can shift the grouping as long as the signs keep repeating, just like the building blocks example. Now we are all ready to solve the big problem. The question starts with a number 1. But from our earlier examples, do we always need to group from the first number? Not necessary. As long as we follow the repeating signs and make equal groups, it will still work. So this time, we will start grouping the number from number 2 instead. That means all the way until 2013. How many numbers are there altogether? Very good. There are actually only 2012 numbers used for grouping. And how many numbers are there in each group? Exactly, it is 4 numbers because the signs repeat as minus, minus, plus. So, how many groups are there altogether in total? Yes, we can just simply take the 2012 numbers, divide by 4 to get a total number of 503 groups without remainder. Now, each group sums up into what value? Yes, each group sums up into 0. So all 503 groups add up to 0. So what is left over now? Only the first number, which is 1. Therefore, the final answer is 1. Exactly. Now, let us do a summary for long calculation with grouping. Firstly, what do we use to group numbers? Exactly, we use the repeating signs and their number relationship as a guide to group these numbers. Moving on, what are the results of each number group usually? Very nice, they are usually equal or they show a certain pattern. And finally, does grouping always have to start from the number 1, first number? Not necessary, as the purpose of grouping is to make our long calculation easier to handle. So, clever grouping matters most for long calculations. To practice for what we have learned in this video, I have this practice question which states to calculate 2 minus 3 and all the way until plus 2016. Now, if you can solve this question, you can comment your answer in the chat box below and I will help you check back your answer if your answer is correct. And this is Teacher Roger signing off. If you have any questions, whether it's related to this problem or not, you can scan the QR code here to join our P1 to P3 study group. And see you in the next video. Bye-bye.